Very good afternoon to all the students. In the previous class, as the first class, we discussed about the concept of vector integration as such. And basically, we looked at how to consider the integral along a line. The line, as I said, it may be a curved line, it's a straight line, or it may be a triangular line, means it is a form of three sides, and so on. So, line need not be straight line, as I mentioned earlier also. Then we consider that classical way of defining the line integral, just like double integral, single integral. And ultimately we ended up with these two terms, or this. So this indicates closed curve, this indicates any other curve. So if you are referring to this example, then it is a symbol used here. Here it's okay, you can use this, use anything. So special symbol is used for this. So now we discuss examples, how to solve them, which is more important for you, because our exams basically are problem oriented and all questions normally are in terms of some problem, solve or evaluate and so on. So now what we do is important. Evaluation of line integral examples, I can say. Evaluation of line integral. So let us take the first example. Compute integral C f dot dr if f is equal to 3xy minus y square j, where C is a parabola, y is equal to 2x square from 0, 0 to 1, 2. So this is a question. So let us read it again. We have to find the integral C f dr if f is given by 3x by I minus y square j, and C is also given as a parabola, y is equal to 2x square. They also mention what point it is moving, from where to where it is moving, simply 0, 0 to 1, 2. So first step is observe what is f. When you look at f closely, we find that there is no k and last part, hence it is a plane vector field, So R, when you take for plane, it is always xi plus yj, hence dr will become dxi plus dyj. R will be this, so dr will be dxi plus dyj. The next step is get the dot product and keep it ready, because we will going to evaluate that value. F dot dr, now it goes as 3xyi minus y square j dot dxi plus dyj. We can directly write the dot product, but I am writing in detail so that all can follow. So when I dot I is taken, it is 1, and when other products are there, they are 0. So it is just the component wise product. So we only get this much as f dot dr. Just take the dot product, means component wise multiplication, I to I, j to j. Remaining terms are 0, as you know very well. I dot I is 1, j dot j is 1, remaining I dot j, j dot I. Whatever they are going to give, they are perpendicular, and hence their product is 0. Now, the most important part about the line integral is only one variable should remain in the end. There cannot be more than one variable for evaluation, because as I said earlier, it is all evaluation with respect to one single variable. It may be x or it may be y, or it depends upon the problem. Here there are how many variables? There are only two variables, and hence either x or y can be chosen as your variable. So always it is preferable to choose x, because that is a natural tendency and we evaluate that quite easily. So let us consider x as our variable. So first task is wherever y is there, replace it by 2x square, and wherever dy is there, replace it by 4x dx when you take the differential. So let us consider so you can call this as equation 1, that is better, so that afterwards you can write it again. So put y is equal to 2x square and dy is equal to 2 into 2 4x dx in 1. So put y is equal to 2x square and dy is equal to 4x dx, because that is the differential of y with respect to x. So when you put that in 1, we get 3x into 2x square dx minus y square. So what is y square? Clear? So y is 2x square, hence its whole square. Now one thing I forgot, draw the figure. Although without that also one can work out. Point is, you have to remember what variable you are choosing and how you are converting, and that limit you have to take correctly. That is the only thing required. For example, here x is 0, 1. That's all. We are making it all x. That's all. So even figure, if you draw, forget to draw, it's okay. Preferably, we expect it. So it is y is equal to 2x square going up, right? It is y square, it is going right. So I can think that this is the part of the parabola under discussion. And notice here, this is a point origin. We have mentioned one point as origin. Other point is 1, 2. You can imagine 1, 2. X is 1, y is 2, roughly here. So this is your point 1, 2. So our integration is in that direction. Our line integration is along OP. Clear? So parabola is drawn only in the first quadrant, and just you can see this point is also in the first quadrant. So there is no need to think about anything else, only that part is enough. So this line OP is our line along which you have to evaluate. So this simplifies to 6x cube. I can take dx common. Now there is 4x raised to 4 into 4x dx. So how much it is? 6x cube minus 16x raised to 5 dx. So the basic procedure is make everything in one variable, preferably x. In this case, at least it is x. Now it's all routine work after this step, because we know the limits of x. We can integrate with respect to x with those limits this function and write the final answer as our line integral. Now, so I will say integral c f dot dr, integral along y is equal to 2x square, I will write f dot dr. I will now write x is equal to 0, 1, because I am choosing everything in terms of x. I hope this is very simple. No explanation required for this. X is 0 to 1 because we are taking everything in terms of x. We get this as 6x cube minus 16x raised to 5 dx. The next step is integrate each term. First term x raised to 4 by 4, you know very well. Second term x raised to 6 by 6. Now you put the limit, 1 is the limit, hence no problem. 6 by 4 minus 16 by 6. Dividing by 2 each, we can write 3 by 2 minus 8 by 3. You take the LCM, which is 6. You multiply this by 3, this by 2. We get 9 minus 16, and hence the answer is minus 7 by 6. So because you are doing it for the first time, maybe first time you will feel that is something difficult or we may not understand easily. But if you do such examples 2-3 times, you will realize that there is a simple logic. It is usual integration only with little care with respect to the curve involved. What is there? Y is equal to what is there? That will make a difference. Suppose I make it x, it will become a line, right? Your procedure will change because dy will be dx. See, this is the link. They will provide. Hence, it is your duty to just manage it the way you want it. Nobody will unnecessarily go to y, correct? All will think about x. If he is so much keen, let him do it, no problem. Somebody wants everything in y, he will replace x by y, dx by dy. Yes, he is welcome. But the problem is always make the things simple, because you don't make things complicated when it is not required. Because when you want to write x in y, you will write root y by 2. Yes. So I am explaining this because better you know it. It should not be gone as unsaid. So I am saying this because it is a lecture and you can always look at that. So I am saying x is preferable here because you can manage comfortably. Y is also fine, but as far as possible, don't think about that, because you know it will be headache for you. Root will be coming up and that will create headache for derivative and all those things. So as I always maintain, avoid fraction, whether it is matrix or anything. Avoid fraction because it is difficult to consider fractions. 1 by 7 minus 11 by 5 like that. Always it's a problem. Suppose it comes in the end, it's okay. But in between also it comes, then it is going to be headache in the next steps. So this is the first example on evaluation of line integral. One plane function was considered, plane vector function was considered. One curve parabola was given, the point was mentioned, first point and the last point both were mentioned, and we obtained this line integral quite easily. Now, it can be treated as work done, but the problem is the work done has come negative. So work is not done by the force, it is the other way around. Hence it is not so interesting to take this example as work done example. Okay, let us go for the next example. As I said, it is more mechanical work for us. As per the problem, just proceed and get the answer. So this example is directly given as work done. So I will say find the work done or compute the work done in moving a particle in the force field. F is equal to, force field is always vector point function. F is equal to 3x square I plus 2zx minus yj plus zk along. So this is your vector point function or vector field, force field, 3x square I plus 2zx minus yj plus zk. Now they are given two possible cases. First, they have mentioned that it's a straight line from some point to some point. So I will write the first case. So along first, we have to find straight line, along the straight line. 0, 0, 0, 2, 2, 1, 3. So first part is finding that integral along a straight line. So they are given two curves in this case. Along one curve you find, other curve also you have to find. So the straight line from 0, 0, 0 to 2, 1, 3. Second one, they are given a separate curve along C given by from x is equal to 2. X is equal to 2. So compared to the previous example, basic difference is they are treating this as a force field rather than just some vector function. They are treating it as a force field. They have given two curves, that is the second difference. Last time there was only one parabola, we obtained the answer. Here we need to find along both of them. Hence the first task is get the value of f dot dr and keep it ready. Always the first task is find f dot dr and keep it ready. Okay, so let us write f dot dr and keep it ready. Then we'll take one by one curve and evaluate. So first thing is, what is r this time? Anybody? R. Shall I take xi plus yj or what? Yes, it cannot be. It has to be xi plus yj plus zk because it is all in 3 dimensions. All ijk's are involved. So the first task is r is xi plus yj plus zk, the position vector of a particle in space. That's why it is zk. So immediately you can tell what is dr. dxi plus dyj plus dzk. So this time the function is different and hence the radius vector corresponding to that is taken differently. Now f dot dr, quickly you find f dot dr. It is 3x square I. I am writing again in detail. 2zx minus y. I will write upper bar for indicating the bracket plus zk dot this dxi plus dyj plus dzk. Although you can directly write, in fact, you can avoid all this, but let it be. On the safer side, writing in detail is always better. So, no chance of any mistake. You simply get 3x square dx plus 2zx minus y dy plus z dz. So, this is your first task always. Whenever you are evaluating some line integral, the very first task is that function you compute. What is that? F dot dr, whatever. So, that is the first thing you have to compute. In this case, it is work done, that is why also it is f dot dr. So, both are same. Now, let us start with the first case. Along what is mentioned, straight line joining straight line from 0, 0, 0 to 2, 1, 3. Now, for this particular case, little bit of knowledge of 3D is required because somehow you have to express the line in terms of equation. Just 2 points are not enough. You should know what is the equation. Then only you can do something. Right? It is uniquely identified by that equation. So, how you manage that? Anybody? Along straight line from 0, 0, 0 to 2, 1, 3. Any way you can write the equation of this straight line? Any way you can write the equation of this straight line? So, you need a little knowledge of 3D, as I said. For a symmetrical form of a straight line, which is always written as x minus x1 by a, y minus y1 by b, z minus z1 by c. So, as you know, x1, y1, z1 is a point on the line. And what about ABC? What about ABC? They are the direction ratios of the same line. So, you should know both the point, one particular point, and then also the direction, because that only makes a difference. This line is different, this line is different, this line is also different. So, all have different directions. They might be originating from the same point, say 115 or something. So, that is why this denominator is very important, because it tells where it is moving, on which direction it is moving. And any additional knowledge that you have, then you know that if you know 2 points, just the difference between the coordinates gives the direction ratios of the corresponding line joining them. For example, if I say 116 and 218 are the 2 points, then the direction ratios of the line joining are 2 minus 1, 1 minus 1, 8 minus 6. I hope you are revising all these things which you did some time back. So, it just gives you 1, 0, 2. Got it? So, 116, 218 are the 2 points considered. Then the direction ratios of that line joining these two, of this line joining, is given by 102. They are the direction ratios. So, if you apply that concept here directly, so please note this. Applying this, take 0, 0 as a point because it is so easy to write the numerator. X minus 0, what are the direction ratios? They simply become the difference, as I said. Which is simpler form. You can write 2 up, 0 down. 0 is indeterminate 1 by 0. That's why this is better, simple. So, x by 2, y by 1, z by 3 is the equation of a straight line now, as per that information given to us. Now, this equality indicates that they are proportional to each other, and always that proportionality constant is in your hand. You can select anything. So, what you mean by this? These are all proportional, they are fixed. But you can say this is 5, you can get 10, 5, 15. You can fix this is 6, you can get 12, 6, 18. You can fix this as 1 by 3. You can get 2 by 3, 1 by 3, 1. Is it clear? So when I choose some particular value, say 1 by 3, I get 2 by 3, 1 by 3 and 1 as the values of x, y, z. So you are choosing particular point, right? So because it is in general, I will prefer to choose it as some t, some parameter t, because the advantage is all x, y, z can be written in terms of parameter t, namely 2t, t and 3t. Hence, see 2t, t. So now you realize very quickly that this is problem where parameter t is going to come into play and your integration will go with respect to t, not x, y or z. Clear? Because we are getting an equation of a straight line which is coming in the form of proportionality, the only way is write it in terms of t and make it very easy for our simplification sake. Now, once you have this, what is the value of dx? You can write. What is dy? You can write. What is dz? You can write. So this you can call it as 1 and then we can substitute for calculation or evaluation. So please write the values of dx, dy, dt. So now we are going to go with the parametric form for t. So x is t. What is x? X is 2t. So dx is equal to 2 dt. Y is t. So dy is dt. dz is 3 dt. Substituting all the values, substituting all in 1, we get f dot dr. So what is x? 3x square. So it is 3 times 2t square. What is dx? 2 dt. Next, what is 2zx? Z is how much? 3t. X is how much? 2t. What is y? Y is t. What is dy? dt. Need not write the bracket. It's okay. Finally, it is z dz. What is z? 3z. Sorry, 3t. And what is dz? 3 dt. I hope you are following what I am doing. This equation 1 is to be used to calculate the expression in terms of parameter t, because everything we have made as parameter t. So we have written x as 2t and dx as 2 dt, y as t and hence obviously dy as dt, z as 3t, hence it will be 3 dt. Now you simplify, just see how much it is. 6 into 4, 24t square plus 6 into 2, 12t square minus t. I am not writing dt, I will write it in the end. This is the expression. Simple addition multiplication. So 12t square minus t and hence total is 36t square minus plus 8t. It is 36t square plus 8t. Now coming to the integration, as I told, our point is 0, 0, 0 to 2, 1, 3. Note what should be t, so that x will be going from 0, y will be going from 0, z equals 0 to x is 2, y is 1 and z is 3, and it is very easy to see that that value has to be t is equal to 0 to t is equal to 1. So just mention for t is going from, why? Because here it is the relation. When you put t is 0, 0, 0, all will be 0. That's the first point. And when you put x is equal to 1, sorry, t is equal to 1, you get 2, 1 and 3, and hence it has to be 0 to 1. Now let us evaluate quickly. Therefore, C f dot dr along line, of course they can write point 0, 0, 0, 2, 1, 3, but I will directly write. So it is 0 to 1, 36t square plus 8t dt. So quickly integrate. So it is 36 cubed by 3 plus, and it's all over. First limit is only available because second is 0. So it is 36 by 3, which is 12. And this is, so work done is 16 units along that straight line. That's joining 0, 0, 0 to 2, 1, 3. So it was a bit lengthy, but yet it is not so difficult that one cannot get. Little care is required in between calculations, and otherwise there is nothing so exciting about this problem as such. Only this extra knowledge of 3D is required, otherwise we won't proceed further, right? It is very much necessary how to express straight line equation, otherwise it's difficult. Now let us look at the second case, and we will look at the second case and evaluate. So I have to write the equations. F dot dr as equation 1, you have it with you. I don't have it here, but I have it. I will write it. F dot dr I will write again. So F dot dr, the original value as equation 1, I will write again. It is better. It is 3x square dx plus 2zx minus y dy plus z dz. This was called as 1, so you need not write it again. I am just writing for my sake. Now we have the curve. Now along C, how it is defined? X square is 4y. 3x cube is equal to 8z. X is going from 0 to 2. Now, we are not in a position to draw the figures that easily. It is not so easy. First one is a part of a parabola, you may say, but it is actually not so. It is in the space. So it's actually like a paraboloid or something. So this is not think about the figure, how it looks like. Even this is also very awkward curve, cubic polynomial it is containing. Hence, don't think about the drawing or the figure involved in this integral. Only work out the way you want it as per your convenience. So again my question is, what is better to convert? X is 0 to 2 they have mentioned, and it is hence obvious to go for X. Just like first example, everything is X. Let us do that and just finish this example. So first step is write Y, which goes as x square by 4. Then write Z also, which goes as 3x cubed by 8. Clear? Just solve it for Z and Y, because everything should go as X, not leave any X and Y and Z. Immediately dy will come, take the differential dy. So numerator will be differentiated and it will just give you x by 2 dx. Differential is obtained on both sides. Dy is 2x dx divided by 4. What about dz here? Now it is 9x square dx, correct? Integral 9x square divided by 8. 9x square divided by 8. This will be 3x square, 3 into 3, 9. This is ready, and hence the next job is substitute all in 1 and make everything x. Substituting in 1, f dr, the expression f dot dr. 3x square dx, we are not going to touch it because it is in x. Now let us go for 2zx. What is z? 3x cubed by 8. Minus into x is also there. Minus y, which is x square by 4. Now what is dy? We have written 2x dx by 4. Always afterwards dx all will be taken outside only, because it's a common thing. Finally dz we have to see z dz. So what is z? 3x cubed by 8. And what is dz? 9x square dx by 8. So next task is write individually all the values. Don't take dx for each term, only take it in the end as a common test. So please write each term correctly. First one, 6 by 8 x4. So you can cancel 4. 3x4 by 4. First term 3x square is there. That we'll write first. Next 3x square by, sorry, yes, 3x4 by 4. 3x square by 4. Next minus x square by 4. Sorry, I could have multiplied also. Let it be minus x square by 4. Outside there is dx. It is, see, it is 2x dx by 4. It is x by 2 dx. I will not write dx as I said. Afterwards I will write. Last term 27x raised to 5 by 64. 27x raised to 5 by 64. And the entire thing is now taken with dx. Now rewrite it again with common terms if they are. So first step is 3x square, no change. I will write this term first, x cube by 8. Okay. Now it is 3x5 by 8 plus 27x5 by 64. If you remove 8, if possible it is good, but it is not going to go because 27 is not divisible by 8. So you can take LCM as 8 only and then simplify. So this is 3x square minus x cube by 8. So 3x5 by 8 I have taken here. So 64 is the LCM. So I have to multiply by 8. 64 plus 27. So I forgot dx. Please write. I hope this is clear. LCM is taken and then multiplication is done. So is it correct or a mistake? So 64, 3 into x raised to 5, 3 into 8 it is, 24 it is. I wrote it as. So 8, 64 is LCM. So it will give you 3x square minus x cube by 8 plus 51, 11. I think it can be further broken down. Is it divisible both? No. So this integral f dot dr along that second curve, x is 0 to 1 now, is 3x square minus x cube by 8 plus dx. So please work out quickly, integrate, simplify. Just see what is the answer in the end. Just work out. You have to integrate. X cube will come because x cube by 3 will be the integral. Then x4 by how much? After integration I have to write. Okay. X raised to 4 by 32 plus 51 by 64, x raised to 6 by 6 between 1 and 0. So limits are, I think the limits are 0 to 2. Yes, their limits are 0 to 2. Just check if they are 0 to 2, it is correct. Don't know what I have given, just check it again. It must be 0 to 2. So please substitute 8 minus so quickly simplify. 2 raised to 5 is 32, 2 raised to 6 is 64. This is 2 raised to 4 is 16 by 32, so it is 8 minus 1 by 2 plus 51 by 6. You can divide by 3 and what is the end? It is 8 plus 51 by 6 can be written as how much? 17 by 3 minus 1 by 2. Is it correct? It's 2. So it goes as 8 plus 16 by 2 and hence it is also going to be 16 units. So with both the curves we end up with the same answer, 16 units. So this example contained first curve and the second curve, and we had to take separately, and according to the situation or according to that problem we had to solve it. First time we used the parametric form, in the second one we use the conversion into x. Now let us write the Green's theorem, which will close this unit. So let me write the statement first, and if possible we will solve one example, so that it means we have started this. So in the next class we can cover few more very fast. We have taken a bit more time, but let it be. So the statement is like this: if phi xy and psi xy are, and even the partial derivatives are continuous. So actually phi x and psi y are enough. So there is no need to write this, only psi y is enough. Are continuous in a region R, or E, anything you can write, in a region R of xy plane, region R of xy plane, bounded by closed curve C. See this word closed curve, highlight it. Then, so the conclusion is here, the theorem statement is ending here now. Notice the statement, last line. Then integral phi dx plus psi dy is double integral R psi by dx dy. So one thing you notice here, we are in the plane, so your R is also dx I plus dyj, means dr is equal to dxi plus dyj, no z coming up. And then some particular expression we are taking where phi dx and psi dy. So now you note that phi dx is like your f dot dr first part. So when you take f dot dr, it is becoming into dx plus into dy in the plane. So that is your phi, and the second one is your psi. But you look at the RHS and you realize that that curve is closed curve, like a circle, triangle, etc. Correct? Your answer is just over this region, double integral over that region. So the link is provided by Green's theorem to link a line integral over a closed curve with the region bounded by that closed curve as a double integral. Clear? Because right hand side is simply this dou psi by dx minus dou phi by dou y dx dy. So if you remember the exact differential equation which was done earlier, there it is similar to that, dou m by dou y is equal to dou n by dou x, then we say that the equation is exact. So very similar to that, the partial derivatives are coming up, and that's why it was necessary to mention phi x, psi y are continuous. So this is psi x and phi y also you can take. Psi x, phi y, anything is fine. Psi x, phi y are continuous, so that they are there, hence you can write it. Okay, because that only is there, that's why we can write it. So psi x and phi y are continuous. So there is only a statement of this theorem, we are not proving it. So whatever function phi is there, whatever function psi is there, you have to notice what it is first. Get their partial derivatives, take the difference, and evaluate that over that region as per the double integration procedure. You know, you need to take the strip, horizontal or vertical, and then proceed. Strip is not required sometime if the limits are constant, so it is depending upon the problem that is involved. Correct? So basically it is evaluation of double integral, which is done earlier, but this side is the routine work that we have just done, that you have to do separately. So when you are dealing with theorem, and especially when you are proving a theorem or verifying the theorem, you need to calculate both LHS and RHS and check whether they are matching or not, just like your vector identities that we had so many last time. Show that this is equal to that. So what you did, LHS we obtained, RHS we obtained, That is another way of, and then check that values are coming same. If they are coming same, it's fine, otherwise there is something wrong. So once there is a theorem and it is well proved, then there is no need to worry, it has to always come correct. Means your calculation should be correct, then there is no mistake. So verification is one aspect, evaluation is one aspect, but because it will be consuming more time, it is verification, then we can only evaluate. So the question is, line integral is evaluated, then you have to use this right hand side to find the answer, because you are evaluating this via this. So evaluate line integral will be given. What you have to do, use right hand side and get that answer without using line integral, using double integral. So line integral is not to be evaluated, because this theorem is for that sake only. Change it and get it. So change to that and then get RHS, get the answer. So let us look at the first example. As I told, phi, psi are important, and so as I said, this is a connection between, if you write, line integral and double integral. Of course, it is closed curve, that makes a difference. It is not any curve, it's a closed curve. It's a connection between line integral and double integral, but it is a closed curve, that is interesting, not any curve. Like a circle, parabola, closed parabola from one side or something. It cannot be just one straight line or one arc. So let us apply this Green's theorem to evaluate something. Apply. So see this, apply Green's theorem to evaluate. So we are not finding both sides. We are only finding one side, the RHS. Evaluate integral x square plus xy dx plus x square plus y square dy, where C is the square, bounded by x is equal to lines, phi is equal to plus or minus 1. So first task is draw the figure quickly as per the given values or whatever they have mentioned. First task is draw the figure. Because it has to be closed, you make sure that it is closed. Then what is phi, what is psi, you identify and then proceed. First I will do that only. Phi is x square plus xy. Psi is x square plus y square. What is required is dou psi by dou x and dou phi by dou y, partial derivative. You can write x because it is partial derivative, x is 0, x 1, so y is 1 giving you. What about dou psi by dou x? Dou psi by dou x is 2x. And dou phi by dou y is just x because it is with respect to y. So what is dou psi by dou x minus dou phi by dou y? It is x, correct? So we get the difference as x. Now let us draw the figure. They have mentioned 4 points are there, plus minus 1, y plus minus 1, mark it. So just join and get that square. Let us say ABCD is that square. Now see the advantage of using this theorem. If you are finding the line integral, you had to go along CD, DA, if you mention the direction anticlockwise, BC, that is the end of it. If you are going along the line integral, that is the LHS as usual method, then you have to find line integral along CD, DA, AB and BC. Hence it looks like this because it is a closed curve, as I said. It's a closed curve. So they have not mentioned that rectangle, but that is understood here. So once closed curve is there, this is the answer. So this is the way to write. So you have to evaluate these 4 values. But when you have that double integral advantage, you need to just take the difference and just evaluate the double integral. By Green's theorem, what you will write now, that integral x square plus xy dx plus x square plus y square dy becomes double integral r x dx dy. Now, the limits of x and y is easy to write. For r, x goes from -1 to +1, y goes from -1 to +1. So limits are -1 to 1, -1 to 1, x square x dx dy. Anyway, you can write because both are the same. Because x is odd function, it will give 0. So the answer is 0. So we have taken only one example. We will go a bit faster in the next class so that we can cover few more things, and if possible we can start the line surface integral also, right? So I hope this class was fruitful and it will benefit you in the long run, because we are trying our best to interact with some way. So thank you very much, and we'll see you in the next class. Some confusion. So this example gave the answer 0. This example gave the answer 0. Now go for the next example. So you need not evaluate this. As I told, this is odd function, so don't worry about that. -1 to 1 is there, so it is 0. Don't calculate, write x square by 2 and all that. Waste of time. Now let us take the next example. Apply Green's theorem to evaluate. Apply Green's theorem to evaluate. Apply Green's theorem to evaluate. Integral C 2x square minus y square dx plus x square plus y square dy, where C is the circle, C is the boundary of the area enclosed by, boundary of the area enclosed by x-axis, and upper half of the circle x square plus y square is equal to a square. They have clearly mentioned what is that closed curve along which our line integral is to be evaluated, and it is to be obtained by Green's theorem. Hence we have to find the double integral, not the line integral. First thing is draw the curve. Okay, phi you can write, no problem. Phi dou phi by dou y, right? Dou phi by dou y. How much? -2y. Dou psi by dou x, 2x, derivative with respect to x. So quickly gives dou psi by dou x minus dou phi by dou y as 2 times x minus -2y, can take 2 common, which works to be 2 times x plus y. Keep it ready. It is required now to integrate that function. So as you simplify that expression, you get that value that has to be integrated, that's all. And then double integral limits you have to select and then over. So figure will draw. They have mentioned it is a circle x square plus y square is equal to a square. Imagine this is your A. It is a semicircle I have to take. So it looks slightly odd on one side. Let it be. I will assume that this is a circle. This is also A0 and all that. Minus A0. 0A. See the upper half of the circle they have mentioned, and the x-axis. So notice what are the boundaries of the curve. The first boundary is the straight line. You can say that AB. Second boundary is that arc of the circle, AB. So how the circle C is formed, how C is written? Line OB plus arc BA. Closed curve. Line AB, arc BA. So that's why I have written on top. Now, we are not using this line integral and getting it, so don't worry. We are just using the double integral. Hence, we need to integrate that double integral over this region. So you need to identify the limits of x and y. So our integration is something like this by Green's theorem. Green's theorem first we'll write and write that RHS. Then we'll see what to do. So as per that RHS, we got it as 2 times, correct? X plus y dx dy. 2 times x plus y dx dy. Next. What are the limits of R? Anybody? Limits of R in terms of x and y. Limits of R. Yes. X is going from minus a to plus a. What about y? Y is a strip now because it's arc that is considered. And what is the equation of the circle? X square plus y square is equal to a square, that is mentioned here. How you write in terms of y? Vertical strip. It is about the x-axis, so positive, hence don't worry. Y will go from origin, the base 0. I hope this is clear, nothing is in this. Vertical limits for the strip, vertical y values, which goes from the base AB and it goes up to the strip along that circle arc, right? Perimeter, or circumference rather. Okay, this integral now becomes, so this becomes 0 to root minus a to a, 0 to root a square minus x square, 2 times x plus y. Now you know what order it is giving as per your knowledge. It has to be dy dx. Whenever the limits contain x, it is ulta, it is y and then x. If the limit contain y, it is x and then y. It is very easy to remember the order for double integrals. So push these two outside, which is nothing to do, and integrate with respect to y. I will write integrating with respect to y. What you have to write in bracket? Treating x constant. Treating x constants. So what do you get? 2 will be out, integrating x square plus, x plus y with respect to y first, as I said. So this will be 2 times minus a to a xy plus, because it is with respect to y, hence x is constant, so y is going to come integral of 1 plus y integration is correct. The next step is just substitute. Remember, I am writing this a square minus x square after squaring, root will go. Now, it is not so difficult to tell something about the first integral. Anybody? No need to substitute a square minus x square is equal to t or anything. There is no need to do anything here. What can you say about the first function? Is it not odd? If it is odd, any integral between minus to plus is gone, it's 0. Hence, I will directly use the fact here. I hope you are getting it. A square minus x square square root is even function, correct? X minus x doesn't change the value, whereas x is odd function. And when you take odd into even, it is always an odd function, as you know. And because it is odd function, answer is 0, because it is minus to plus. If it is not minus to, this is different, but it is minus to plus, hence it is 0. This 2 gets cancelled. What can you say about the second term? Now you will know very easily. This is definitely even, because it is a square minus x square, it's squares. A square can be written as a square x raised to 0 also, there is not a problem. So 2 gets cancelled. Now minus a to a square minus x square, I can write 2 times 0 to a square minus x square dx. Reason is this is even. Due to it is even function, we can directly write 2 times 0 to a square minus x square. So simplify this, integrate with respect to x. What is the answer? Yes? What is the answer? So I think we have forgotten one a outside. So this 2 is there continuously. Yes, 2 is there. Okay, what is the answer now? 2 is coming due to even function. What is the answer? A cube minus a cube by 3. 2a cube by 3 into 2. So it is 2 times. So even the polar coordinates can be used for that, but I don't think it is necessary. You can manage using even function because the other solution is given in terms of polar coordinates. Put x is equal to r cos theta, y is equal to r sin theta here and everything. See, polar coordinates normally are used whenever circle is there. Although here it is not so required, but still polar coordinates normally are used when circle is involved because the radius vector will be constant. Constant limit will come for that. Angle is also constant. That is the advantage. Theta will be always 0 to something, pi by 2. And radius also is constant. Hence it becomes very useful to use the polar coordinates. So here we didn't use it, although in the other part solution is there. You can manage without that also. Clear? So in this case, also we have used the Green's theorem to evaluate the value of the line integral with the double integral, and that is the advantage. So evaluation of along AB, evaluation along BO, BA along that arc is not required. See how complicated it would be to find this integral. You have to use the polar parametric form of the circle and all that. If you are very much keen, you can use it. So suppose somebody is very much keen in finding the theorem or verifying the theorem, he has to find the line integral along this. That is not big task. X is going from minus a to plus a, y is 0, dy is 0, fine, you can get. But along this, both x and y are varying, hence you have to use the parametric form given by x is equal to a cos t, y is equal to a sin t. Done? So you are moving like this. And then what is the angle theta? That is t. It has to be 0 to pi. So if you are thinking about this integral to verify the theorem, suppose it is not asked this is different, then you have to move this way. Put x is equal to a cos t, y is a sin t, and then proceed. So you should know that it is possible to evaluate along the circle using parametric form of the circle. So this example was also on Green's theorem to evaluate this value, line integral. Now we are using, we are not only using, we are verifying Green's theorem. Verify Green's theorem. See this. Here, a lot of work will be required. You have to find the LHS as well as the LHS for xy plus y square dx plus x square dy, where C is bounded by y is equal to x and y is equal to x square. It is bounded by y is equal to x and y is equal to x square. Both the curves are familiar to you, so I don't think there is any problem regarding this. Already in double integral many times you might have come across these curves. First is y is equal to x. See here y is equal to x square, so it has to be going to the top like this. Already we have taken one curve in the first example. So this is the equation y is equal to x square. That was 2x square, this is 1x.